Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0105, indicates that the manifold absolute pressure (MAP) sensor is out of range, signaling an issue that needs attention in the Honda CR-V 2017 to 2022 models. The MAP sensor plays a crucial role in the vehicle's engine management system by measuring the pressure within the intake manifold, which directly relates to the engine's air intake volume. This data is essential for the Powertrain Control Module, PCM, to adjust the fuel injection and ignition timing for optimal engine performance. If the MAP sensor readings are too high or too low, it can lead to decreased engine efficiency, poor fuel economy, and increased emissions. The sensor is typically located on the intake manifold or near the throttle body of the engine, making it accessible for troubleshooting. Understanding how to interpret the readings from the MAP sensor, along with the DTC generated, is vital for effectively diagnosing and resolving this issue. The MAP sensor is a pivotal component that measures the pressure inside the engine's intake manifold. Specifically, it helps determine the air density that is entering the engine, which is critical for optimizing fuel delivery. This sensor operates in conjunction with the PCM, which uses the information from the MAP sensor to calculate air-fuel mixture ratios for combustion. Typically mounted on or near the intake manifold, it is relatively easy to locate. The sensor works by generating a voltage signal that correlates with the pressure it senses. Thus, any significant deviation from the normal operating range could trigger the DTC P0105. This DTC points to concerns such as improper voltage signals being sent to the PCM, making troubleshooting essential to restore normal operation and prevent further engine performance issues. Several potential causes can lead to the generation of DTC P0105. The most common culprit is a defective MAP sensor, which may malfunction due to wear or electrical issues. Additionally, loose or corroded connections can impair the signal transmission to the PCM, causing erroneous readings that trigger the DTC. Wiring issues, such as shorts or breaks in the wires connecting the MAP sensor to the PCM, can also result in signal discrepancies. It's important to conduct a thorough inspection of the wiring and connector terminals for any visible damage or corrosion to ensure they are delivering correct signals. Knowing these potential causes allows technicians to focus their troubleshooting efforts where problems are most likely to lie. The symptoms associated with DTC P0105 often manifest as reduced engine performance. This can result in sluggish acceleration or decreased power output, making it difficult for the vehicle to maintain speed. Additionally, you may observe poor fuel economy as the engine struggles to find an optimal air-fuel mixture due to incorrect MAP signals. Another common sign is illumination of the check engine light on the dashboard, which serves as an indicator that the engine management system has detected a fault that needs attention. Drivers may also experience rough idling or stalling. Therefore, recognizing these symptoms early can prevent further mechanical issues and ensure timely repairs. Understanding these indicators is essential for Honda CR-V owners to maintain their vehicle's performance. In the first troubleshooting step for DTC P0105, begin by turning the vehicle ignition to the on mode without starting the engine. This allows the Honda Diagnostic System, HDS, to communicate with the vehicle's electronic systems. Next, utilize the HDS to check specific parameters related to the MAP sensor, focusing on the voltage readings. The critical threshold value to observe is less than 0.23 volts, which indicates a potential issue with the sensor performance. Assess whether the current condition matches this threshold. If the parameters are confirmed to align, it suggests that the failure is replicated, which allows you to continue to Step 3. However, if this isn't the case, proceed to Step 2 for further diagnostics. Conducting this initial check establishes a foundation for identifying the underlying issue, ensuring efficient troubleshooting. For the second troubleshooting step, again, ensure the vehicle is in the on mode. Following this, use the HDS to verify the specifics of the MAP sensor's current conditions by checking if the signal is more than 3.39 volts. This higher reading indicates a potential fault in the MAP sensor or its connection to the PCM. Should the current conditions match this threshold, you can conclude that the failure is indeed duplicated, allowing you to move forward to Step 7 for further diagnostics. However, if they do not match, this signifies an intermittent failure. Thus, the system may appear normal. It's crucial to inspect the connections for any poor fittings or loose terminals at both the MAP sensor and the PCM. It can cause erratic behavior and complications in the signal readings. Having diagnostic snapshots recorded can aid in reproducing errors under the same conditions, providing additional insights into the underlying problem. In the third troubleshooting step, begin by turning off the vehicle and setting it to the lock mode. This ensures that all electrical systems are powered down for safety. Next, disconnect the MAP sensor's 3P connector to isolate it from the system for diagnostic purposes. After disconnection, turn the vehicle back to on mode and utilize the HDS to check the sensor signal again. Focus on whether the current conditions match the expected threshold of less than 0.23 volts. If the readings align, it confirms that the issue resides within the wiring or the MAP sensor itself, and you can proceed to Step 6 for further testing. Conversely, if there is no match, this indicates a different potential failure, leading you to Step 4 for further diagnosis. This step effectively narrows down the potential problems, guiding your troubleshooting process. During the fourth troubleshooting step, measure the voltage present between the test points specified in the instruction manual, ensuring that the vehicle is in the on mode and that the MAP sensor connector is disconnected. The specific test points to check are the female terminals at positions number 1 and number 3 of the MAP 3P connector. You should be aiming for a reading of approximately 5.0 volts. If this voltage is verified, it suggests that the MAP sensor is faulty and in need of replacement for proper engine function. However, if the voltage does not meet the expected value, this indicates additional issues, prompting you to advance to Step 5 for further investigation. This examination is crucial, as the MAP sensor directly impacts the engine management system. Accurate voltage measurement aids in determining the next course of action effectively. For this fifth step in troubleshooting, begin by powering down the vehicle to off/lock mode. Using the HDS, jump the SCS service check signal line and wait for more than 1 minute to allow the system to reset. Following this, disconnect the PCM Powertrain Control Module Connector C, ensuring it is safely powered down to prevent electrical shocks. Next, check for continuity between the indicated test points while ensuring that the MAP sensor 3P connector is also disconnected. The test points for this check include female terminal number 3 of the MAP sensor 3P connector and pin number 41 of the PCM connector C. If continuity is confirmed, this indicates that the VCC1 wire is functioning correctly, allowing you to check informational resources regarding the DTC or symptoms. However, if continuity is not established, you will need to repair any breaks or frays in the VCC1 wire between the PCM and the MAP sensor. This step is essential for ensuring complete circuit integrity and functionality. In Step 6 of the troubleshooting process, Once again, set the vehicle to off-lock mode for safety. Utilizing the HDS, jump the SCS line and allow a minute for the system to stabilize. Disconnect the PCM connector C as a precaution for accurate measurement. Subsequently, check the continuity between the specified test points, the female terminal number 2 of the MAP sensor 3P connector, and the body ground. Finding continuity here confirms that the PB wire is in good condition, indicating no shorts exist in this pathway. If continuity is absent, it suggests a short in the PB wire, potentially creating erratic signals, which could contribute to the DTC. Repairing any faults in the PB wire is essential to ensure that the MAP sensor can communicate accurately with the PCM. This step emphasizes the importance of wire integrity in the diagnostics process. Moving on to the 7th troubleshooting step, start by turning the vehicle to the off-lock position. Disconnect the MAP sensor 3P connector to ensure accurate testing free of external signals. Then, connect terminals A and B within the MAP sensor connector using a jumper wire, facilitating a direct connection for voltage testing. After establishing this connection, turn the vehicle back to the on mode to power the systems. Utilize the HDS to check the parameters once more, focusing on whether the MAP sensor output is more than 3.39 volts. If the conditions are satisfied, proceed to Step 8 as it indicates the potential for an issue elsewhere in the system. However, if the voltage does not meet this threshold, it substantiates that the MAP sensor itself is faulty, warranting its replacement for proper vehicle operation. This step allows for clear isolation of the problem while facilitating accurate measurement. In the 8th troubleshooting step, once again, set the vehicle to off-lock mode to ensure safety during testing. Remove the jumper wire that was used in the previous step from the MAP sensor 3P connector, returning the sensor to its standard operating conditions. Next, turn the vehicle to the on mode and measure the voltage between the 2 specified test points, with the MAP sensor still disconnected. Focus on checking the voltage between female terminal number 1 of the MAP sensor connector and terminal number 3. A successful measurement should yield close to 5.0 volts. If this voltage is produced, it affirms that the SG1 wire is functioning correctly, allowing you to progress to Step 10 for further verification. Alternatively, if the desired voltage isn't present, this indicates a break or fault in the SG1 wire between the PCM and the MAP sensor, prompting further investigation and repairs. This step reinforces the significance of accurate voltage checks in diagnosing wiring issues. Proceeding to the 9th troubleshooting step, initiate by switching the vehicle to off-lock mode. Utilizing the HDS, jump the SCS line, allowing for a reset period exceeding 1 minute. Disconnect the PCM connector C to maintain accuracy during testing. Engineer your test check for continuity between the designated test points while ensuring that the MAP sensor connector is disconnected. The test points specified include female terminal number 1 of the MAP sensor 3P connector and pin number 42 of the PCM connector C. Establishing continuity will confirm the functionality of the SG1 wire. If the connection is intact, in cases where continuity is absent, the implication is a fault in the SG1 wire, necessitating immediate repair to maintain proper signal transmission from the MAP sensor to the PCM. This critical step aims to secure the integrity of the wiring involved in the MAP sensor operation. Finally, in the 10th troubleshooting step, ensure that the vehicle is in off-lock mode initially. As done in previous steps, jump the SCS line with the HDS and wait for at least 1 minute for the system to reset. Once again, disconnect the PCM connector C to facilitate direct circuit verification. Proceed to check for continuity between the specified test points, particularly focusing on female terminal number 2 of the MAP sensor 3P connector and pin number 45 of the PCM connector C. If continuity is confirmed, this suggests that the PB wire is functioning correctly, and you may proceed to consult any relevant service information or consider substituting with a known good PCM should further issues persist. However, if continuity is not established, this would indicate an open in the PB wire between the PCM and the MAP sensor, necessitating appropriate repairs. This closing step ensures the complete path between components is intact for successful sensor operation. Once all necessary repairs related to DTC P0105 have been completed, it is essential to verify the effectiveness of those repairs. Begin this verification process by initiating a test drive of the vehicle under various driving conditions to confirm that the MAP sensor is functioning correctly. After the test drive, utilize the HDS to check for the reappearance of the DTC. If the DTC does not reappear, it typically indicates that the repairs have been successful and the vehicle is operating as intended. However, if the DTC does return, this may suggest ongoing issues within the sensor system or wiring that were not adequately addressed. In such cases, revisiting the previous troubleshooting steps may be necessary to ensure all potential areas of failure have been comprehensively evaluated and repaired. Confirming that the repairs have resolved the issue is a vital step to restore optimal functionality. To prevent the reoccurrence of DTC P0105, preventive maintenance is essential. Regular inspections of the MAP sensor should be conducted to ensure it is free from debris and functioning correctly. Checking all associated electrical connections can help prevent issues related to corrosion or looseness that can lead to faulty sensor readings. Maintaining a clean wiring harness is equally important. Dirt and grime can negatively affect the electrical signals transmitted between the sensor and the PCM. By implementing these regular checks, you significantly reduce the likelihood of future DTC triggering and promote the longevity of your vehicle's performance. Staying proactive with maintenance will not only enhance the MAP sensor's reliability, but will also ensure the optimal operation of the engine management system. In conclusion, understanding the implications of DTC P0105 is crucial for maintaining the performance of the Honda CR-V from the years 2017 to 2022. This DTC indicates that the MAP sensor is out of range, which can affect engine performance and efficiency. Performing thorough troubleshooting allows you to accurately identify the root cause, whether it be a faulty sensor, wiring issues, or connection problems. Ensuring that repairs are made correctly and verified through testing helps to restore the vehicle's functionality. Finally, implementing preventive maintenance further ensures that such issues do not arise in the future, promoting a reliable vehicle operation. Being knowledgeable about this process empowers owners and technicians alike to address and rectify any arising concerns effectively. Please like and subscribe to the channel. See you next time.